Hello everyone, I'm Julius Marquez, and together with my partner Nicole Vitug, we are here to present to you our thesis topic called Deep Learning Approach in Gregg Shorthand Word to English Word Conversion. Shorthand writing or stenography is the art or method of writing quickly, replacing with symbols, characters for letters or words. Stenography has been used in a variety of fields of work. For an administrative field, it is one of the fundamental skills that a secretary must acquire in order to have an administrative job. In the medical field, medical transcriptionists use stenography as a tool for recording their patients' information and other medical reports. In the law field, during legal proceedings, court stenographers use stenography to catch up in recording testimonies. Even television journalists sometimes use stenography to record the interview accurately and completely. Our main objective is to develop a device that will automate the conversion of Gregg shorthand words into English words. For specific objectives, we're going to build a dataset composed of features of handwritten Gregg shorthand acquired through crowdsourcing. Develop a deep learning model as the main approach for the Gregg shorthand to English translation, and integrate this system to a capable device, which for our case is the Raspberry Pi 4. To measure our results, we're going to use word accuracy as our statistical approach. The study's main focus is on the recognition and translation of Gregg shorthand words using the Inception version 3 model in the TensorFlow platform. The shorthand words are limited to the top 135 commonly used legal terminologies according to a study from the University of Arizona. Lastly, the prototype does not have the ability to enhance the image or input, so they must be taken in a well-lit environment for a more effective feature extraction which can lead to more accurate results. The benefits of this study are: it will enable stenographers to convert their shorthand documents into storable computer text files without the disadvantage of manual translation, which can be very tedious. It will reduce the amount of time transcribing Gregg shorthand written papers, and the study may also be an evidence of ideas for further study of the technique used in the information collected. So here is our conceptual framework. For the input, image capturing is the initial process that captures the image in an enclosed image acquisition system. The process group consists of the recognition development, where there are two main systems involved: the recognition and transcription system with the use of Inception version 3 CNN model. Output will display the converted Gregg shorthand image to English word. And here is also its corresponding hardware block diagram. The camera will be used for the image acquisition for the input. It is connected to the Raspberry Pi, where the recognition development will take place. Then, the LCD, which is also connected to the Raspberry Pi, will be responsible for displaying the translated word. The researchers used a CNN architecture called Inception version 3, also known as GoogleNet version 3. This architecture is 42 layers deep, and it also enables the users to avoid complex image preprocessing, thus allowing people to directly input images to it. In addition, this type of CNN architecture has a reputation for having a low error rate for large-scale image classification tasks. So the figure here shows the TensorBoard graph for the CNN architecture Inception version 3. The input image should first go to the layers called a convolutional filter. The purpose of these layers is to extract features from the image that was input. The first convolutional layer is the one responsible for extracting the so-called low-level features of an image, such as color, edges, and the like. For each succeeding convolutional layer, the CNN architecture adjusts to extracting higher-level features of the image, giving the system a complete understanding of it. The input also goes to the pooling layers, which are used for extracting positional invariant and rotational features for the input. The max pooling layers serve as the noise suppressant layer. These layers have a denoising ability as well as dimensionality reduction, while the average pooling layer simply uses dimensionality reduction. The classification occurs in the softmax layer where it calculates and gives the score to each class, which is represented as their confidence. The class having the highest confidence will of course be considered as the classification of the input image. So for this study, we have an overall of 135 classes.
So the next one is the training procedure. On the left side of the screen is the flowchart of the training process. So we have prepared 120 different images for each of the 135 legal terminologies with a total of 16,200 training data sets. So from the flowchart, the first process is the building of datasets by means of collection of datasets generated by a court stenographer in a group of chosen individuals. That will serve as our training set. The next one is training a CNN model. Each image will undergo layers which will act as a filters, with every layer converting the image to its increasingly informative representation. The next one is the CNN image classifier that will identify the Gregg shorthand word from the image. Next is that image will undergo layers in a looping manner until the desired percentage is achieved, and if the desired accuracy is not yet met, adjust its parameters. So for the testing procedure, all 135 legal terminologies written in Gregg shorthand will each consist of 10 trials per legal terms, meaning 10 images per legal terms, with a total of 1,350 testing datasets. So the first process of the testing procedure is insert the paper with the written Gregg shorthand word on the paper holder. Second one is on the LCD screen, press the capture button. Next one is to translate that captured image, press translate button. And lastly, if you want to save that translated image, just press file, then go to save, then add to CSV records. So this is our results. Since there are 135 legal terminologies that will serve as our classes, all 135 of them were tested but would only show 2 words for the purpose of the result. So the first word is the fraudulent. So from the table 1, as you can see from trial 1, 2, 3, 4, 5, 7, 9, and 10, it produced a correctly predicted output, while the trial 6 and 8 produce incorrectly predicted output. So these are the sample results for the legal term in Gregg shorthand word for table 1 using the Python app GUI. So letter A is the correctly translated word and letter B is the incorrectly translated word. So for the next word is the prejudicial. As you can see from trial 1 to 10, it produced a correctly translated output or correctly predicted output. So this is again the sample result of that legal term using the Python app GUI with correctly translated word. So this is some of the incorrectly translated word. Due to its similarity in writing, we have complaint, cause, convict, conveyance, finding, findings, file, felony. As you can see, they look alike but some minor changes in detail. So for our statistical testing, we use word accuracy, which is equal to C over N times 100. So C represents the words that are translated correctly, while N represents the total number of words tested. So as you can see on the table 4, the number of words that are translated correctly was 739. The total number of words tested is 1,350. So the accuracy rate produced 54.74%. So for our conclusion, the first one, only 739 out of 1,350 legal terminologies that were tested were correctly translated. Number 2, due to some similarities in writing of other Gregg shorthand words with minor changes in detail, the system recognized the captured image and translated incorrectly. The third one, the Raspberry Pi camera affects the quality of the captured image, resulting in incorrect translation. And lastly, the word accuracy rate of the system was computed and it resulted to 54.74%. And based from our objectives, our conclusion, the researchers were able to create legal data sets. The deep learning model was able to implement and use in the translation of the legal terminologies in Gregg shorthand to English word. And lastly, the researchers were able to translate some of the legal terms in Gregg shorthand to English word via Raspberry Pi 4. So for our recommendation, first one is increasing the number of data sets. And second one is high quality camera or scanner, either of which that could produce a better image quality. And that's all. Thank you.